Hello, I'm Dan Sweeney from MathSpec Incorporated. In this video, I'd like to go through setting up your mass error window. The mass error window is really important. If it's too tight or too low, you may miss the correct compound. On the other hand, if you make it too high, if you always run it like 5 millidaltons, you will get many more hits that are probably irrelevant. And also the amount of time it takes to do an analysis will increase quite a bit as the error window increases. A good compound to use to check your mass error window setting is leucine enkephalin. It's pretty easy to get solutions of this commercially, and the fragmentation is pretty well known. So I've listed here 10 of the larger fragment ions of leucine enkephalin and the theoretical values. Now in this spreadsheet, I've copied in the experimental values from massbank.jp, and this spectrum is CO000247. Now I'd like to compare these values to the theoretical values to try to get some idea of where to set the mass error window for this data set. Now in this spreadsheet, I'm going to knock out rows here so that we can get the whole thing on the screen. Okay, now we can compare the values in column B, the experimental values, with the values in column F, which are the theoretical. And this is the mass difference in millidaltons, which is 1,000 times the difference in those two columns. And as we go higher in mass, the error goes a little more negative and also gets a little greater. Now in this case, I'm not interested in the average error. I'm interested more in the worst case. The worst case here is 3.67 millidaltons. Now I wouldn't set the mass error window at 4, even though it would work for this data set. I would go one higher, which is 5. So I'm going to compare this data set for leucine enkephalin to another compound, the spectrum of methionine enkephalin, and I'll use a mass error window of 5 millidaltons. Thank you.